Hello, welcome to this lesson. In this video, we are going to solve this question I have on the screen using the simplest method. So the question says maximize z equals 40x1 plus 30x2 subject to x1 plus x2 less than or equal to 12, 2x1 plus x2 less than or equal to 16, where x1 and x2 are greater than or equal to 0. So let's look at how you are going to solve this question. So to solve this question, the first thing I'll do is I'll write down the objective function, okay, and then change the inequality expressions towards equality expressions. So we are going to have the objective function, which is z equals 40x1 plus 30x2, okay, and then now I'll change the inequalities to equality. So we are going to have x1 plus x2 to be equal to 12. That's the first constraint equation. Then we are going to have 2x1 plus x2 to be equal to 16, which will be the second constraint equation. Okay, so now, what you're going to do is that you're going to introduce some variables known as slack variables. Okay, slack variables. Okay, so we're going to add these variables to each of the three equations that we have. But for the objective function, what you're going to do is that the slack variables don't contribute to the value that we get for z. Okay, so for this reason, we are going to make the coefficient of the slack variables 0. And because we're given two constraint equations, we are going to have two slack variables. Okay, but in the objective function, their coefficient will be 0 because they don't really contribute to the value that you get for the objective function. So let's say if z was a profit, okay, the slack variables will not contribute to the profit value that we want. Okay, so for that reason, you're going to make the coefficient 0. So we are going to have z to be now 40x1, okay, plus 30x2 plus 0s1, which is the first slack variable, plus 0s2, which is the second slack variable. Okay, so you are going to add the first slack variable to the first constraint equation. Okay, so we are now going to have x1, okay, plus x2, and then we add the first slack variable which is a coefficient of 1, so we're going to have 1s1, and then we'll add the second one also, but we'll make its coefficient 0, so we're going to have 0s2. Okay, this will be equal to 12, and then for the third one also we're going to have 2x1 plus x2. Okay, and then I'll add the first slack variable, but I'll make its coefficient 0. Then I'll add the second one and make its coefficient 1. This should be equal to 16. Okay, so now what you're going to do is that we are going to equate any two of these variables to 0. Okay, but I'll start with making x1 and then x2 0. Okay, so I'm going to say that the x1 should be equal to 0, then x2 also should be equal to 0. When you do this, you will call x1 and x2 as non-basic variables. Non-basic variables. Okay, so when we are done, we will now solve for s1 and then s2 in the two constraint equations. Okay, so when I solve for s1 in this constraint equation, we are going to get s1 to be equal to 12, and then when I solve for s2 in this equation, you will get s2 to be equal to 16. So we will now call s1 and s2 as basic variables. Okay, so one thing you have to know is that in this case, anytime you equate a variable to 0, we call it non-basic. Okay, and then those that are not 0, which is the s1 and then s2, will now become the basic variables. Okay, that's after making s1 and then s2 0 and then solving the two constraint equations for s1 and then s2. Okay, so now let's go to the table. So this is our first table, and then if you look at this table, for the first row here, the values there are the coefficient of uh, x1, x2, s1, s2 in the objective function. Okay, so if you look at this equation here, okay, the coefficient of x1 is 40, okay, and I have 40 there, and then x2 is what 30. I have 30 there, and then s1 and then s2 are what 0. So I have 0 2 there. So that's what the first cj row means. And then you have another cj here. Okay, those will be the coefficients of the basic variables. Okay, we'll talk about that later in the video. And then we have the right hand side here, which are the values that we will get. Okay, after setting our non-basic variables and then solving for the remaining variables. So let's look at that, and then have our zj value here, and then cj minus our zj value. So let's look at how you're going to do the computations in this table. So for this table, our basic variables are s1 and then s2, right? So I write s1 here, s1 and then s2 here. Okay, so I write it under the basic column. Okay, and then you know that the coefficient of s1 in the objective function will be 0, right? Which is what you wrote here. Okay, now this is called the standard form. Okay, we call these equations. We see that these equations are in the standard form. Okay, so you know that in the standard form the coefficient of s1 is 0, and then the coefficient of s2 is also what 0, right? So we write the zeros here. Okay, so for this part of the table, okay, what you're going to write is that you're going to write you're going to fill it with the coefficients of the variables in the constraint equations, okay, that have been written in the standard form. So if you look at this equation here, okay, the coefficient of x1 is 1. Okay, before that, let's not forget this part of the table. Okay, so for this part you are supposed to write the variables there. You're going to have x1, x2, and then s1, s2. Okay, let's not forget that. Okay, so you now see that the coefficient of x1 is 40, right? And then the coefficient of x2 is what 30. That of s1 is what 0, and then s2 is also what 0 in the standard form for the objective function. Okay, so now for this part of the table, okay, what I'm going to write there will be the coefficient of the variables in the standard form for the constraint equations. Okay, so for x1, okay, its coefficient in the first constraint equation was 1, and then the second one was 2, and then for x2 we have 1 1. Okay, and then for s1, for the first standard form, s1 was 1, and then it was 0 in the second, and then this one also s2. Okay, this one also s2 was 0 here, and then it was 1 here. And then for the right hand side, we are going to write down these values that we got after equating x1 and then x2 to 0. So that will be 12 and then 16. Okay, so now let's look at how you are going to calculate our zj and then cj minus zj values. Okay, so in this table, for you to identify your basic variables and non-basic variables in this table, what you do is that you look at the column, okay, with look at unit columns, okay, which are the columns that have zeros and ones in them. So if you look at s1 here, okay, if you look at this column here, this is a unit column, right? Because we have just 1 and 0. Same here. Okay, so the variables that are on the unit column are known as the basic variables. Okay, so in this case s1 will be our basic variable, and then s2 will be our basic variable, and then we already said that here. Okay, so that means that in this table s1 and then s2 are basic variables. So that's one way to confirm from the table, and then you have already written them here under the basis column, so that should also tell you. Okay, so the variables that are not on non-unit columns are now the non-basic variables. So you look at x1, you don't have a unit column here. Same here, you don't have what a unit column here. So now in this case, x1 and then s2 are what non-basic. Okay, so in this table, we will see that what x1 will be equal to 0 since it is non-basic, and then x2 will also be what equal to 0, right? Okay, so let's look at what you are going to do next to get the zj values. Let me free out some space here. Okay, so to get the zj values, okay, I'll write down the objective function in a standard form. Okay, so we have 40x1 plus 30x2, okay, plus 0s1 plus 0s2, and then this should be equal to what? Z, right? But I'll make it zj in this case. Okay, so we already know that for this table, x1 and then x2 are equal to 0, right? So wherever you see x1 and then x2 in this equation, you will put 0 there. So let's just make them 0, because wherever you are going to see them, you're going to put 0 dot there. So at the end, you're just going to have this part here, which is also 0 though. So you're going to have 0s1 plus 0s2 to equal to what? Zj. Okay, so now what you do is that you use this formula here to find your zj values for the zj row. Okay, so what will happen is that when you consider the s1 rows, okay, when you consider the s1 row, all the values in that row will become our s1. Okay, then when you consider the s2 row, okay, when you consider the s2 row, all the values there will be our s2. So all these values will be our s2. Okay, so let's take note of that. Okay, so let's look at what you are going to do. So what you do is that for this formula, you have what? 0s1 plus what? 0s2. That should give us what? Zj, right? Okay, so you know that for the first zj value, this will be our s1, then this will be what? Our s2, right? So you substitute it into this, and then you know that you're going to get 0 multiplying 1 plus 0 multiplying 2, which will give us what? 0, right? So our first zg value what will be what? 0. Okay, and then you know that if you do it for the other values also, you're going to get 0, because this formula itself is what? 0. So you're going to have 0 here, 0 here, 0 here, and then 0 here. That means that the z value what will be 0 in this case. Okay, that's if z was profit, we're going to say the profit value what will be 0 in this case. And then remember that we said earlier on that s1 and s2 doesn't contribute to the value of what? ZJ, right, or the value for the profit. And then what you have here, you have S1 and then S2 to be the basic variable. So when you use that one to calculate for the value of Z or the profit, they are not really contributing. So you're just going to get what? 0 for this case. So take note of that, because S1 and then S2 don't make any contributions to the value of what? Z. Okay, so let's continue. So let's find the Cj minus what? Zj. Okay, so for that one, we know our Cj values for the column, which is 40 here. So you subtract Zj from it. So you're going to have 40 minus 0. That gives us 40 for the first column. Then you're going to have 30 for the second. Then here you're going to have 0, 0. And then for here, what I write is that what you normally do is that for us to know whether you've gotten the optimum solution, you look at the last row, which is the Cj minus the Zj row, and see if the values are less than or what? Equal to 0. But in this case, we have two values that are equal to 0 and then two that are not less than or what? Equal to 0. So I'll just write false here, which means that you've not gotten we are not there yet. Okay, but depending on how your lecturer wants it to be, if the lecturer doesn't require you to write anything, you just leave it that way. Okay, but in this case, I'll just write false here. Okay, to help us know that we have still not gotten our optimum solution. Okay, so now that we've not gotten our optimum solution, what do we do next? So let's go what you are going to do next. Okay, so the next thing you're going to do is that we know that S1 and then S2 don't contribute to the value of Z, okay, which is the value that we want to maximize, right? So what do we have to do? Our main goal here, okay, will be to take out S1 and then S2 from the basic variable column, and then bring in x1 and then x2, since x1 and then x2 are in the objective function. Okay, so you have to take away s1 and then s2 from the basic variable column, and then send x1 and then x2 rather there. So how do we do this? So to send x1 and then s2 to the basic variable column, what you do is that you look at the last row, okay, and then consider the highest non-negative value, which is 40 in this case, okay, and this 40 is on the x1 column, right? So that tells you that the next variable that you are going to send to the basic variable column will be x1. Okay, but how do we know whether the x1 will replace s1 or s2? To find out which one you are going to replace, we divide this 12 here, okay, we're going to divide this 12 here by this 1 here. Okay, so we're going to have 12 divided by 1, and then that'll give us 12. Now divide 16 by 2. Okay, that'll give us what? 8. So now we are going to consider the smallest value after the ratio. Okay, and then comparing 12 and 8, 8 is the smallest, right? And 8 is on what? Is on the S2 row. So what that means is that you are going to replace S2 with what? X1. Okay, that's what that means. So I'm going to redraw the table. So I will redraw the table. I have my new table here. Okay. Okay, so this is our new table. Okay, let me write the variables in there. We're going to have x1 here. We will have x2 here. We will have s1 here, and then s2 here. Okay, now we know that our basic variables will be s1 and what? X1, right? So I'll have my s1 here, then I'll have my what? X1 here. So we've taken s2 away because we have replaced it. We've replaced it with what? X1. So you know that from the standard form, the coefficient of s1 will be 0, and then that of what? X1 will be what? 40. So I write 40 here. Okay, so how do we get the value that will be here? Okay, so we know that s1 and then x1 are now the basic variables, right? So if you look at the column that we have x1 in it, okay, we must make that column what? A unit column, right? Because we said that the columns that the variables that falls on the unit column are known as what? Basic variables, right? So that means that so far as x1 is here, okay, we must make this column here what? A unit column. So how do we do that? So look at the old row 2. Okay, let me name this row 2, and let me name this what? Row 1. Okay, so you look at the old row 2, okay, and look at and find a way and then make this first value here what? 1. How do we do that? You can make 2 1, okay, by just dividing by what? 2, right? So that means that what you are going to multiply through the old row 2 by what? Half. When I do this, I'm going to have 1 here because for the first one, you're going to have what? Half multiplying 2, which will give us 1. And then for the second value, you're going to have 1 over 2. And then for the third, you're going to have 0. For the fourth, 2, you're going to have 1 over 2, and then for the last value you're going to have 1 over 2 multiplying 16, which will give us what? 8. Okay, so now this is our new row 2. Okay, let me name this row 2 star. So we're going to use this new row 2 to get a new row 1. Okay, so how do we do this? Okay, so what we want to do is that we want to get a 0 here. Okay, we want to get a 0 here. So you look at the old row 1, okay, and then look at the first value, which is 1. So how do you make that value 0 using the new row 2? To do this, you see you have 1 here, right? And you know if I subtract this 1 from this 1 here, you are going to get what? 0 here, right? So that means that we should subtract the new row 2, okay, from the old row 1 to get our new row 1. So we're going to have row 1 star, okay, to be equal to row 1, okay, minus row 2 star. Okay, that's what you are going to do. So let's carry out that operation. So the first value, we know that the old row 1 value is 1, and then the new row 1 value is what? 1. So when you subtract, you're going to get what? 0 here, right? Okay, and then the old row 1 value for the next entry is 1, and then subtracting half from 1, okay, will give us what? Half, right? So we're going to have half here. Okay, so let's continue. So now we have the next value to be 1, okay, and then we are subtracting this 0 here from that one, so you are still going to have 1 here, okay, and then the next value is what? 0. Then subtracting half from what? 0, so you're going to have minus half here. Then the next value is what? 12. Then you're subtracting 8 from 12, so we're going to have 12 minus 8, which will give us what? 4. So we'll have what? 4 here. So this will be our table. Okay, so this will be our table. Okay, so I think now you can look at this table and still tell us the basic variables, right? So first of all, we know that s1 and what? X1 are the what? Basic variables number. How do we further confirm from the table? We look at the x1 column and then we see that it is what? A unit column, right? So that means that it's true. x1 is a basic variable, and then s1 also has a unit column, so that's also what a basic variable. Okay, and then x2 and then s2, which do not have unit columns, are now the non-basic variables, right? So from this table we are going to say that what x2 is equal to 0, right? And then let me clean this. Okay, so I'm going to say that x2 is equal to 0, right? And then s2 is also equal to what, 0, because they are non-basic variables. So what we are going to do next is that, let me free up some space. Okay, so what you are going to do next is that you are going to consider the standard form of the objective function, right, which is 40x1, right, plus 30x2 plus 0s1 plus 0s2. This will give us what, the zj values. Okay, but you know that for this table, x2 will be 0 and then s2 also be what, 0. That means that for this equation that we have here, wherever you are going to see x2, okay, you will put 0 there, and then wherever you are going to see s2, you will put what, 0 there. So and then we are going to have 40x1, right, plus 0 what, s1, and this should give us what, our zj values. Okay, but you know that when you multiply 0 by any number here, we are going to get 0, right? So all this becomes what, 0. So then we are going to have 40x1 to be equal to what, zj. Okay, so this is how you are going to get our zj values for this new table. So we are just going to multiply 40 by what, the x, sorry, it's x1. Okay, s1 equals what, zj. So this is how you are going to get all our zj values, by just multiplying 40 by what, the x1 values. So let's start. So for the first column, we have x1 value to be 1. So you're going to have 40 multiplying 1, which will give us what, 40, right? And then the second one, you're going to have 40 multiplying half. Okay, so that gives us what, 20. Okay, then next one, you're going to have 40 times 0, which will give us 0. Then 40 times half, okay, which will give us 20 again. Then you're going to have 40 times 8, which will give us what, 300 and what, 20. Okay, so you know that these are our x1 values now, right, for this computation. Okay, so we use that to get our zj values, which we've already done. So let's look at what you're going to do next. Okay, so now let's find the cj minus what, zj. So I'll subtract this 40 here from this 40, right? And then you know you're going to get 0, so I'll have 0 here. And then I'll subtract 20 from 30, that'll give me 10. And then I'll subtract 0 from 0. Okay, that also give me 0. And then 0 minus 20, that give me what, minus what, 20. So we look at the last row, which is the cj minus the zj row, and then looking at that also, we have two values that are equal to 0. We have one that is less than 0, which is the minus 20. And then we have one value which is not less than or equal to 0, so which means that we've not gotten our optimum solution. So this is also false. Okay, you can choose not to write anything there depending on how your lecturer wants it to be. Okay, so now this is our second table, but you know that this is not the optimum value that you want to get. Okay, so in the normal circumstance, you are supposed to look at the zj values and then look at the highest one. In this case, that's for 320. Okay, but the last row doesn't satisfy the condition you want, so that means that you can't see that the optimum value for z will be what, 320. So you have to draw another table. So let's continue. So I'll clean this table here. Okay, let me clean that one. Let me clean what we have here also. Then let me send this table. Okay, okay, let me bring this table here. All right, so now I'm going to draw another table. Okay, so let this be the next table. Okay, so we have the third table here. Okay, so let's look at that. We have our x1 here, x2, sorry, s1, s2. Okay, so now when we look at the previous table, you realize that the basic variables were s1 and what, x1, right? And then we are saying that to get the maximum value of z, you must not have the non you must not have the slack variables in the basic column, because the slack variables don't satisfy or don't contribute any value to the value of what z, right? So that means that for this column here, for us to get our optimum solution, you must not have what this s1 here. So you have to take the s1 out. So how do we do that? So let's look at how we do that. So at this point, okay, you should know that the next variable that you're going to be taking out is what? S1. Okay, but you don't just take it out. You just have to do some calculations to prove that, okay, that's the variable that you are supposed to what, take out. So just take note of that. So we look at the last row, and then you see that the highest non-negative value is what? Is 10, and then that's on the what? X2 row. So that tells you that what? X2 will have to what? Replace one of the what? Basic variables. Okay, but in this case it's s1 that I want to take away. Okay, so just make sure that at this point, after doing your calculation, s1 is the variable that you are going to be eliminating. But to further confirm this, you are going to divide this 4 here by half. Okay, by half, so that will be 4 times 2 over 1, then that will give us 8, and then here also you are going to have 8 divided by half, that will give us what? 16, right? So the smallest is what? 8. So that tells you that what? X2 will replace what? S1, since the 8 is on the S1 row. Okay, so in our new table, we're going to have X2 here, then we have what? X1. And then from the standard form of the objective function, you know that the coefficient of what? X2 is what? 30, right? And then that of what? X1 is what? 40. Okay, so I write it there. All right, so let's look at the element that, or the entries that we are going to have here. Okay, so for that one, okay, we know that x2 is now a non-basic sorry, it's now a basic variable, right? Which means that this column here must be a unit column. Okay, so how do we do that? That means that you must change this half here to 0, and then change this half here what? You must change this half here to 0, okay, and then change this one to, we must change this one, sorry, we will change this one rather to 1, okay, and then you change this one rather to what? 0. Let's take note of that. So when you do that, then you are now going to have a unit column. Okay, so you are going to have we need something like this. We need 1 here, and then we need 0 here. Okay, and then we need 0 here, and then we need 1 here, so that we can say that what x1 then what x2 are the basic variables. So let's look at how we are going to do this. So to do this, you know that to change this half here to 1, I'll just have to divide by half, right? So we are going to take the new row 2, sorry, new row 1, new row 1, which is what? Row 1 star, right? Then you have this to be row 2 star. Okay, so we divide the row 1 star by what? Half. Okay, when I do this, you are going to have 0 here. Okay, we're going to have 0 here, and then we will have 1 here. Okay, and then 1 divided by half. Okay, that will give us 2. Okay, so we're going to have 2 here, and then minus half divided by uh, half, that will give us what? Minus 1, and then 4 divided by half, that will give us 8. So we're going to have 8 here. Okay, so this is our new row 1, so let me name it as row 1 star star. Okay, all right, so now what we do is that we want to make this half here 0. Okay, so how do we do that? So we are going to do that using the new row 1. Okay, and then looking at the new row 1, we have 1 here in the column where we want to make the half what? 0, right? So how do we do that? So I'll have to multiply this one here by half, right? So I multiply this one here by half, and then I subtract it from this half here. You know that you are going to get what? 0, right? So our new operation will be the new row 2, okay, will be equal to the row 2 star, okay, minus 1 over 2, okay, multiplying the new row 1, which is what? Row 1 star star. Okay, so let's take note of that. So let's look at that. So the first entry, okay, we are going to have 1, right? We are going to have 1 minus, okay, 1 over 2, okay, multiplying this value, which is what, 0, right? So that gives us what, 1 here. Okay, and now the R2 star value will be half. Okay, and then that will be minus half multiplying 1, which is what, this one here. Okay, so when I do that, you are going to get 0 here. Do you get it? So let's do it for the remaining ones. So that one also, we are going to have um we are going to have this 0 here. Okay, so you have 0, okay, minus 1 over 2, okay, multiplying these 2 that we have here. Okay, so that what, times 2. So you're going to get what, minus 1 here. Okay, and then for the next one, you're going to have half, okay, minus 1 over 2, okay, multiplying this what, minus 1. So when I do that, you're going to get 1 here. Okay, you have 1, and then for the last value, you are going to have 8, okay, minus 1 over 2, multiplying what, 8. Okay, when I do this, you are going to get what, 4 here. Okay, so let me clean some things from the table to make it look a little nicer. Okay, so now this will be our new table now. Okay, so now let's calculate for our zj and then cj minus what, zj values to see if we've gotten our optimum value. Okay, so now we know that for this table, x1 and then x2 are now our basic variables, right? Which means that s1 will be 0 and then s2 will also be what, 0, right? So wherever so now we are going to consider the objective function again, which is 40x1, right, plus 30x2 plus 0s1 plus 0s2, right? This should give us what, the zj values, right? So wherever we are going to see s1 and then s2, we just put 0 there, so at the end they are just going to be given a 0. So in all, we are going to have the zj values to what, 40x1 plus 30x2. That should give us the zj values. So now let's use this formula to calculate for the zj values. So you know that these values, okay, you know that these values will now become our x2 values, right? And then these ones will now become what, our x1 values. Okay, so let's use that to find the zj values. So for the first zj value, okay, we are going to have x2 to be 0 and then x1 to be what, 1. So let's substitute that into this formula. Okay, when I do this, you are going to have 40 multiplying 1 plus 30 multiplying what, 0, right? And then you are going to get what, 40. For the second value, you are going to have 40 multiplying 0, okay, plus 30 multiplying 1, okay, then that gives us a value of what, 30. And then for the next one, I'm going to have 40 multiplying minus 1, okay, plus 30 multiplying what, 2. Right, so I'm going to have minus 40 plus what, 60, right? This will give us a value of what, 20 here. Okay, and then for the next one, you're going to have 40 multiplying 1 plus 30 multiplying what, minus 1. Right, so you're going to have 40 minus 30, which will give us what, a value of what, 10. So you will have what, 10 here. And then for the last one, you're going to have 40 multiplying 4 plus 30 multiplying what, 8. So let's see what you are going to get. So 40 multiplying 4 plus 30 multiplying 8, that gives us a value of what, 400. So we are going to have what, 400 here. Okay, so now let's look at the cj minus what, the zj. So for this one, I'm going to have this 40 being subtracted from this 40. Okay, and then that'll give us 0 here. 30 minus 30 will also give us 0. 0 minus 20 give us minus 20. 0 minus 10 give us what, minus 10. So all these values are less than or equal to 0, right? So this is what's true. So that tells us that we've gotten our optimum solution. But how do we know the optimum value for z? So you look at the zj values that you got, okay, and then you see the highest value, which is what, 400. That means that the maximum value for z will be what, 400. And then that happens when x1 is equal to 4 and then s2 is equal to what, 8. And then that gives us what, the z to be what, 400. So this is how to apply simplex method in solving maximization problems.